We'll wait a minute or two because there's only 10 of you, and hopefully we can pick up a few more. Um, I just have to go turn a light on because it's too dark for me. There we go. Now I just have the halo above my head like I'm all important and knowing when really it's nothing to do with that. Oh, I think we've picked up a whole slew of people. Okay, maybe just two more. I had a couple people ask about doing like questions about the assignment before we start. Um, if you aren't done, don't worry. Even though it shows up, oh, so and so passed an assignment in late, I honestly don't care. Um, as long as they come in eventually, and even then, if I'm gonna probably give you one sometime later this week on uh, inverses and radicals. If you have the majority of the assignments done to the majority of it being decent, that's all that's important. Um, but hopefully we can get some more stuff done. So assignment questions. I pulled it up here. If nobody has any questions, we'll carry on.
I don't understand. Of course, I have a question.
That's fine.
I don't understand when you're doing like the vertical thing, like finding all the transformations, right?
Yep.
For some of them, if it's a negative, you change it to a positive, and then some of them you do the reciprocal, and I'm just confused about that part.
So because of how if we built tables of value and had like 10 times more time, um, when we deal with the x part of any of these, the horizontal, um, the sign of any horizontal translation shifts. So if, and it kind of is like come on, oh, I do, what? Oh, good. How do I get rid of that? That doesn't help. Oh, you've got to be kidding. Go away. Delete? Oh, that's ridiculous. Sorry about that. What the hell is going on? So, Lauren, you remember parabolas. Like if you had a quadratic that was x minus 2 squared plus 4, that has a vertex of, we always switch this part, so 2 and 4. Uh, we don't really do horizontal stretches with quadratics just because it's a matter of moving them in and out. It's the same idea as when we wrote equations for the radicals. Well, because you can move it algebraically for a radical function or a parabola, a horizontal stretch doesn't really do anything. For a trig function, it does because it changes the period of the function. But for a lot of things, they're one and the same. It's just a matter of how it's stated. So, like if you're looking at if it's inside this F bracket, you kind of do the opposite thing. If it's outside, you leave it the same. Does that help a little bit?
What if the vertical stretch is 1?
Well, that's fine.
You do it. You How do you do the reciprocal for that one? Do you leave it or?
Well, if the vertical stretch is 1, the reciprocal of 1 is 1. So you just leave it.
Oh,
Yeah.
You can go.
3b. Stretched horizontally by a factor of a half. So your b value would be reflected across the x, which so this one is, it says write an equation. Personally, I'm going to write a mapping rule first. And if I say reflected across the x-axis, which coordinate changes, the x or the y? If we think about that, if the x coordinate originally is here and it's, oh, that's a really crappy one because it's right on the axis. That was dumb. So reflected, now where is, oh, awesome. We're having a good morning. Okay, apparently we're green now. So if I have a point here that is x and y, and I reflect it across the x-axis, which means I'm going to put it down here. So, so which changes, the x or the y? If it's reflected, yeah, it's only the x. So that's where you would see it in a mapping rule. If it's a reflection across an x-axis, it's going to be, it's kind of the opposite coordinate changes. So if this was reflected across the y over here, well, the y coordinate stays the same and the x becomes negative. What? For which? Well, so like that would be there, but this one is just writing an equation. So you could figure out whether like you're looking for A, B, H, and K, and then the reflection, you just tack a negative sign wherever that would go, right? And you're trying to put it into, so like that. So you can identify, and if it's a reflection, you're just putting a negative. It's not officially, and it's not really, but you end up usually sticking it in front of the A or the B value. So if it's a reflection across one axis, it's gonna, if it's a across the y-axis, you're changing your x, so you would put a negative here. If you were reflecting it across the x-axis, you're changing the y. So the A deals with the y and the B is the x part. Does that help? Yeah. So this one is just write an equation. So there's no coordinates with that at all. You're just, if A is 4, B is 3, H is -2, and K is 1, you just put the numbers into that equation. Where you need to worry about points would be something like here, identify an ordered pair. Once you have the mapping rule, you're swim. So if I don't want to use the exact same thing, now can I just select most of that? Whoops, that's not what I wanted to do. Copy it and paste it because I think I can move. I'm going to get rid of the lines because I don't want them right now. Do 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 do. Put A there, B there, C there, D up here. Whatever the equation is, or the, so we have a function like that. Do 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 do. 3 minus 1. So if you have a function like that, you need to write a mapping rule. So the x goes first. There's no number in front, so it's just x plus 2 goes to minus 2, 3y minus 1. And that point is not going to be, let's change this to, well, whatever. We're not going to be able to actually plot that last point just because the graph is too small. So that's one thing we need to be able to do is generate a mapping rule. So the point A is negative 3 and negative 1. So the new A point, well, there's not supposed to be a comma here, x minus 2. So negative 3 minus 2 is negative 5. Negative 1 times 3 is negative 3, minus 1 is negative 4. So A prime is way down here. So you have to be given points on a graph to actually use them. So 0 minus 2 is negative 2. 2 times 3 is 6. 6 minus 1 is 5. So negative 2, 1, 2, 3, 4, 5. C is 2 and negative 1. So 2 minus 2 is 0. 3 times negative 1 is negative 3. Minus 1 is negative 4. And then D is the one that, well, where it is. 5 and 3. 5 minus 2 is 3. 9 minus 1 is 8. So 3, 1, 2, 3, 4, 5, 6, 7. 3, 6, 7. And D would be there. And then it's just a matter of technically joining those. So it's been pulled up and moved over, really, is what it's been done. Does that help?
Oh yeah.
So that,
You wrote the, sorry,
go ahead, Lauren.
when you wrote the mapping rule, you did x minus 2, so you changed that?
Yeah, the X always is going to switch.
Okay.
And the Y stays the same. It's just a function of how you would build a table of values because it's about actually getting the original point. But so we good from there? If,
Sister McKay, I completely forgot about the assignment because my sister had an emergency surgery.
oh, geez, that's no good. Is she okay?
Uh,
Is it an
yeah,
appendix?
no, it's gallbladder.
Oh no. Oh,
Yeah.
been there, done that. Got the T-shirt. Hopefully she doesn't turn yellow, because then she has to go back to the hospital. That's no good. It's no good at all. So whenever you get it done, I'm not super worried if it's today, tomorrow. I mean, I'll probably get 20 of them, and it's going to take a little while to go through everything. So I'm not in a rush, so to speak, not yet, anyhow, to get them marked. So the sooner the better, but if it's like it's going to tell you you turned it in late, and if by chance you try to submit something and it won't let you, let me know and I'll switch it because I don't think I changed that. Um, and then I love how, well, I thought it was 7. Did someone unsubmit? Yeah, you can pass it in kind of whenever, so we're good. All right. On Friday, we looked at radical stuff. Mm, we kind of went over that checkpoint, and oh, I should have done something different. Today, I want to look. I guess. Well, we may not get through all of it because I don't want to keep everybody too long, even though it's rainy and cruddy and all of that. So it's not like you're gonna go outside and do yard work unless it's inside a barn, and then that's important as well. So we did basically stating transformations, doing mapping rules, and all of that. We looked at a table of values. So again, we're going to do radicals. We're going to eventually do exponentials and logarithmic functions. And it's all, the graphing is done based on this kind of mapping rule idea. Once you get the idea with the shape, you're generally okay. So we looked at how to write an equation. The h and the k are just that endpoint at the end. You have to figure out the normal function goes this way, so there was a reflection in the y. So we built kind of this part, and then you can either kind of look at the idea of over one up something. This one had a vertical stretch of 3, but if I go over a ninth and up 1, I get to that 1 vertical. So there's technically, like I said earlier with quadratics, a vertical and a horizontal stretch are the same thing. You can look at it differently, and there's the relationship. Well, B is, why am I getting the blue circle of whatever? The A was 3. Well, if I take a 3 and put it under a radical, we get 9, which gives us a horizontal stretch of that. Another thing in here is the square. Well, yeah, it's like when you start typing with equations, the square root of a function. So we've just looked at the square root of x. Well, we can look at a whole bunch of other functions. When you take the square root of something, we have some things we have to worry about. So it's only defined when the function is bigger than 0. And we should all hopefully see that this is okay, because when it's less than 0, can we take the square root of a negative number? So when f of x less than 0, it's negative, and that doesn't work. So we're going to look at some fairly simple ones just because it's a time crunch, because it's now May. So we got to get a bunch of stuff done. This is probably the last radical sort of thing we'll do. And then we'll start into logs and exponentials. So if we have f of x equals 3 minus 2x, we can plot this. We can look at a whole bunch of things. If I build a table of values, 2 times negative 2 is negative 4. 3 subtract negative 4 is, oh, let's make it pretty, 7. 2 times negative 1 is 2. 3 minus, or 3 plus 2 is 5. 3 minus 0 is 3. 2 times 1, so that's a 1. This is here for a reason. 2 times 1.5 is 3. 3 minus 3 is 0. 2 times 2 is 4. 3 minus 4 is negative 1. And that would be negative 3. So this is negative 2, 1, 2, 3, 4, 5, 6, 7, negative 1 and 5, 0 and 3, 1 and 1. I'm going to try to put that in there. There's our 1.5 and 0, 1, negative 1. So if I ask you to draw that graph, it should be all right. So, oh, what are you doing? Okay, we'll do it this way. Draw our graph. Grade 9, grade 10 math, no big deal. But if I ask you to take the square root of that function and graph the square root of 3 minus 2x. So we can start at the top or the bottom. What we're doing if we are looking for the square root of the function, we don't have to do any thinking. The square root of 7 is the square root of 7. It's less than 3, 2.6-ish. Makes sense. It's a positive number. The square root of 5, 2.1, give or take. We're not really going, oh, wow, I was off. 2.2. The square root of 3 is, well, the square root of 3, which is approximately 1.7. Well, now we get to something that's nice and simple. The square root of 1 is 1. Awesome. Pick this point for another reason. The square root of 0 is 0. The square root of -1, -3, all of this other bit does not exist. This should kind of draw back to when we did just the square root of x. We can't go into the negative direction. We can have graphs in there, but when we take the square root of a negative number, we don't have anything. So 1.5, hey, that point's the same. That point's the same. So 0 and 1.7 is about there. -1 and 2.2 is about there. -2 and 2.6 is about there. Oh, what if I do -3? If I just kind of extend my table back, 3 plus 6 is 9. The square root of 9 is 3. So -3 and 3. This is a linear function. Oh, that was awful. It was horrible. So it's going to, if it's a linear function, it's going to have a similar shape, regardless of what that function is, to one of the graphs that we looked at before. And we could technically, because the red graph is y equals the square root of 3 minus 2x, well, that's the square root of -2 x, son of a, -2x plus 3. Well, I can kind of factor that -2 out. -2 over 1 up a half, or over 2, -2, and x minus 1.5. So if I gave you that equation, well, you could say that has a horizontal translation of 1.5. It's got a reflection in the y. It's got a stretch of 2, which, because we have that kind of 1.5 over 0.5 up 1, gives us a stretch of 2. So any linear function, if you take the square root of it, you're going to generate some sort of curve like we did yesterday. We need to look at the domain. Well, the domain, all of the x values are less than, well, whatever that point there, 1.5. The range, well, in this case, all of the y values are bigger than or equal to 0. Now, this is a word that hasn't really come up. And it's going to, I think it's formally defined in one of the next slides. A variable is fundamentally something that changes. We talk about the x variable. We picked values for that. If something is invariable, the word we use more often is constant. But if something doesn't change, we can say invariant. So we have for a linear function, two invariant points, points where the y-coordinate doesn't change when we take the square root. One of them is 1 and 1. The second one is 1.5 and 0. Because when you take the square root of 1, what do you get? 1. When you take the square root of 0, what do you get? So these two kind of points where we have a 1 and a 0 are going to actually become very important because they're ones that don't change regardless. Wherever that line is, if you have another line that goes like that, well, that point and that point don't change when we take the square root of it. So we know that that would go somewhere like that. So we've got some kind of rules, relative locations. We have when f is less than 0, when it equals to 0, between 0 and 1, when f of x equals 1. And these are all we can kind of, because it's y equals f of x. So this is when, whoops, the y coordinates are less than 0. This is when the y coordinate isn't 1, stupid. It's 0. This is between 0 and 1. This is when y equals 1 and y is greater than 1. So it's a relative thing. If I have f of x and it's less than 0, and I take the square root of f of x, well, can we, if it's negative, can we take the square root of it? Not yet. In 12b, you talk about those. It doesn't exist. So this is where anything isn't there. The square root of 0 is 0. So we say these coincide. They're the same. There's no change in that point. The square root of 36, or well, the square root of 0. If it's 36 and 0, well, that point, when you take the square root of the 0, it's still the same. So this is between 0 and 1. Now, this is where we get the whole, well, what's the square root of a quarter? It's a half. So technically, the square root of f of x is above the function. So it's really hard to tell here based on my graph, but we have this itty bitty little spot based on how that curve is. If I go through and we're looking at a y value of 0.2, and I take the square root of that, 0.2 is on the blue line, the square root of it on the red line is 0.4. So any 0.44, yada, yada, yada. So there's that one little instance where the radical or the root function is the same. This is the second point. The square root of 1 is and then generally this is going to be, because once you get above 1, the square root of 2 is 1.43, blah, blah, blah. The square root of 3 is 1.7. The square root of 4 is that sort of thing. So the kind of interesting part about this and the things that are important this is going to give us usually an endpoint. We'll look at a couple different things where it's not necessarily, but these are our invariant points when f of x equals 0 and f of x equals 1. So it's 10:30. I want to keep these a little bit. Um, an invariant point is a point on a graph that remains unchanged when any transformation, whether it's a square root, there are potentially invariant points on any of the transformation graphs that we've done, the trig graphs. If you want to kind of get a little bit of a head start and you have some graph paper, you can sketch the graph of those four. I'll go through them quick tomorrow. Those are all like slope y-intercept, vertex form, vertex form. Um, yeah, that's what I wanted. Yeah, and that's just shifting it up too. And then we'll look at tomorrow um, what the graph of for each graph, the square root of that. So that's I don't want to take too much time. Some of you have all sorts of other things to do. I don't know if you look at the newspaper. There was wait, what day is today? It might be in the Kings County Record. Tomorrow was a picture about stores selling Girl Guide cookies, and Madison Snyder was in the picture. Um, but hopefully we have another what? We're on day 15, 28, day 28. That's our goal. Day 28 with nothing, and then school's not going to go back because schools are cesspools. And there was an article this morning I saw about our school's going to be the quote unquote next nursing homes in this because Ontario and Quebec and the states and all of those with this COVID thing are having big problems in nursing homes because you have a bunch of people who are elderly or sick and they're the ones who are most susceptible to this, but they're all close together. New Brunswick's been ridiculously lucky and we haven't got it in nursing homes, and that's a good thing. But if we go back to school in the fall and they say, well, you can't hang out in the lobby. Well, some of you, well, most of you guys are, except for maybe Brady, maybe Aiden, are rule followers. So you're going to follow the rules and listen. But school could be, hopefully, God willing, there's a vaccine and we can all go back to school. But it could be very,
Ignore your comment.
oh, I know you're a rule follower.
I'm just hoping like school doesn't get canceled because I want my hockey.
Uh, for a hockey season, I think you really need to hope they find some sort of vaccine, or because you have a bunch of people, it's okay, you can play hockey, but you can't check, you can't get within 3 feet of somebody. Well, that makes for a little bit boring hockey. But the other alternative, and as much as I hate Donald Trump, the there's a chance that this kind of goes away. It's not likely. The first, the SARS that was in, oh gosh, 10 or 15 years ago. It's the same type of virus, but it wasn't as contagious as this one. But it just, like, there's no vaccine for it because it's gone. It just became, it just kind of, I don't know exactly what happened. Talk to Mr. Bellier, he'd probably have way better answers. But what we want is a vaccine. And if you don't like vaccines, well, this is one to get. You should get them all, but that's a whole other thing. But if there's no other questions, that's kind of it for today. We'll look at the rest of that tomorrow and then move into logs and exponentials, which will be interesting because that's what ties into this sort of thing. So I will bid you adieu until, well, this afternoon or tomorrow. Uh, have a good day.
McKay, wait, I have a question.
Okay, I haven't left yet.
Okay, good. So for this, um, are you gonna like put those notes on it? Like, I can't explain it.
Like,
Like the stuff that we just did, are you gonna put it on?
yeah, the blank stuff should be there. I just put
Okay.
it up this morning. Um,
And is that the assignment or anything, or is that just practice questions?
so the assignment would be there already, right? In under assignments, but in the file section, because I think you guys can still see this. I don't. Under radicals, it should be there. 3 square root of a function, and I'll put the notes that, like, I'll put a separate one with what we did.
Wait, what do you mean?
So, like, see how I've got completed.
Mm-hmm.
That's the notes that, like, if you open one of those up, once it goes, like,
Oh, okay. I think I printed those off. But I don't.
yeah. So I'll go through and do the same sort of thing and put stuff up, and I'll post this to YouTube and the link later.
Okay, so if we finish the assignment from last week, then we're good. Like we're caught up, right?
Yeah, I'm gonna probably put another one up soon,
Okay.
at some point this week, but it'll just be on um, the RF4 and 5, or 5 and 6, sorry.
Okay.
The inverses, because there's not a whole lot in either of them. I will also make sure it's shorter than the transformations one, because I looked at it and was like, oh, this is okay. Maybe it's a little long. It's like, nah, it's okay, and left it. And probably made a horrible mistake, but
Okay, that sounds good. So, okay, I'm good.
okay,
Thank you.
perfect, no problem.
I have another question. I know I'm asking you a lot of questions.
No worries.
Um, how